Good morning. I'm Gustin Marosales and I'm the first presenter for Group 4. The topic is all about the effects of wind, current, squat, shallow water on the ship handling while maintaining safety navigation. And first, let's talk about the wind. Vessel head to wind with a headway. As you can see in the picture, vessel making headway through the water and heading directly to the wind. Wind is now well forward for our ships, and in fact, it's very close for to P, and the wind is exerting no turning moment or sideways force on the vessel. And comparatively small change in relative wind directions, either by alteration of course or wind fluctuations, will place the wind on the vessel bow. The whole of the side of the vessel will now be exposed to the wind, and the wind will move aft. The following effects will be experienced on vessel head to wind with the headway is the turning force will now develop a turning moment about P, tending to turn the vessel into the wind again. The wind force will also develop a sideways force into the vessel, away from the exposed side. Head to wind, therefore, the vessel is course stable, provided the ship maintains headway through the water. If the ship has a large stream by the stern, a wind will be further forward with reductions or even loss of course stability. This can sometimes result in a rapid and violent loss of control.
Following effects will be experienced. Letter A. The wind force will develop a strong turning moment about P or pivot, tending to turn the vessel's bow further away from the wind. Letter B. The wind force will develop a sideways force on the vessel, away from the exposed side. Head to wind, as soon as the vessel starts to make sternway through the water, she loses course stability and the bow will pay off away from the wind, sometimes quite rapidly.
Vessel stern to wind with headway. Vessel making headway through the water and with the wind directly astern. P is forward, a long distance from W, which is well aft. A comparatively small change in relative wind direction will move W forwards. However, W is still some distance above P. The following effects will be experienced. The wind force will develop a strong turning moment about P, tending to turn the vessel's stern further away from the wind. The wind force will develop a sideways force on the vessel away from the exposed side, making the headway with stern to when the vessel loses course stability and it is difficult to steer. This effect is greater when there is also a following sea or swell. If the ship has a large stream by the stern, W will move further forward and loss of course stability may be generally less pronounced but still a potential danger.
Vessel stern to wind making sternway. So the vessel making sternway through the water and with the wind directly astern. P has moved aft and fairly close to W, which remains even farther aft, and a change in relative wind direction will eventually move W forward of P. So what would be the effect of your vessel stern to wind making sternway? So these are the following effects will be experienced. The first effect that you will experience is the wind force will develop a turning moment about P and tending to turn the vessel's stern back into the wind. And the second is the wind force will develop a sideways force on the vessel and away from the exposed side.
My topic to be discussed is current. A current is a continuous directed movement of the seawater generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, cabling, and temperature and salinity differences. Deep contour, shearling and configuration, and interaction with other current influence a current direction and strength. Ocean currents are primary horizontal water movement.
Ocean current plays a very important role in ensuring the stability of the ship. The effects of currents, therefore, must also be considered when handling ships in waters. Effects of currents are important, especially when the ship is under effect of onshore winds, near offshore platforms, while maneuvering in narrow channels and open seas, or in inland waters or harbors. When the ship is in harbors or in inland waters, and the current is at constant strength and direction, the ship's handling becomes considerably easier. That's all.
Ship's squat. The squat effect is the hydrodynamic phenomenon by which a vessel moving quickly through a shallow water creates an area of lowered pressure that causes the ship to be closer to the seabed than would otherwise be expected. The squat effect is approximately proportional to the square of the speed of the ship. A squat is also mentioned as a factor in the collision of the bulk carriers.
Squat is the reduction of a vessel keel clearance caused by the relative movement of a ship's hull to the surrounding of body water. The squat effect is the hydrodynamic phenomenon which a vessel moving quickly through shallow water creates an area of lowered pressure that causes the ships to be closer to the seabed than would otherwise be expected.
I'm going to discuss about shallow water. So, first, the effect of shallow water on the ship is more ship's power is absorbed by the water due to increased friction. So, usually sinkage is greater forward than aft for ships of tanker speed and displacement in any depth. So, in this situation, we can encounter this if we are going to onboard a tanker ship. So, we can um, we can justify that the sinkage or the usual sinkage area is greater than forward than aft. So, turbulence interferes with rudder and propeller effectiveness. Signs that the ship has entered shallow water conditions can be wave making increases at the forward end of the ship. So, ship becomes more sluggish to maneuver. So, when we say ships become sluggish to maneuver, so um, the movement of the ship is slowly. So it moves slowly or it can be inactive. So RPM indication will show a decrease. So if the ship is in open water condition without breed restriction, this decrease by 15% of the service of RPM. So if the ship is in confined channel, this decrease in RPM can be about 20%. So if we are in open water conditions, the RPM will decrease about 15%, while if we are in a confined channel, it turns 20% decrease of our RPM.
Number 6. RPM. RPM indication will show a decrease. If the ship is an open water condition without breadth restriction, this decrease may be 15% of the service RPM. If the ship is an confined channel, this decrease in RPM can be about 20% of the service RPM. Number 7. There will be a drop in speed. If the ship is an open water condition, it may amount to drop 60% of the service speed. Number 8. The ship may start to vibrate suddenly because of the entrained water effects causing the natural hull frequency to become resonant with another frequency. Number 9. Pitching reduced due to cushioning effect of water under the keel. And that's all. Thank you, sir.